And here begins a lecture on creating these objects. So first, we remember from last time that we have a vehicle that's going to be declared as abstract. We can't create vehicles and hope to be successful because we're going to declare these as virtual, meaning anyone who inherits from it, like this car object, it's going to have to make sure that it declares them down here. Okay, so with that said, let's go in and create this right now. So here I am in code blocks. I've already set this up. I've created a little lecture workspace, and here's my main. I have just a handful of these .h files, and again, they're just nothing. They're empty. So what I want to do is I want to create a new .h file, and that .h file will be what's going to be something. But just to show you, because you can see my .h files aren't appearing here, but when you do File, New File, let's create another H file, and I shall call it, how about airplane? That's a vehicle. Oops, spell it right. Airplane.h. It needs to know where it's going to go. Obviously, I'm going to put it here with all the others. And CodeBlocks does this weird thing by putting a double letter at the end. I don't know why. You don't put an H there, it won't do it. You put an H there, it puts a second one there. Oh well. So I will save it and finish. Okay, you can see down here in the headers, there's the airplane.h, but trust me, the others are there as well. So don't panic if all of a sudden you're not seeing your H files here when you close it and go back into it again. You can certainly find them in the workspace if you just use a file browser to find it. Okay, so we won't be using airplane, but there it is. Vehicle, that's the one. So vehicle, we know is abstract. Now let's give it some libraries first off. So let's include IOStream. Let's include string, because we're going to need that. Okay. Now, using namespace std as always. Okay, so there we go. Class vehicle. Okay. And no, again, has a mind of its own. There we go. Alright, so in here is going to be the class definition, and down below here will be all of the vehicle, scope, whatever operators. So first, I know based on the UML, it'll be type, and then as string, and then distance, hours, fuel as double. I removed type from the car because when the car creates an instance of itself, it's going to it will tell vehicle what it is. So when we have the getter, we'll get the type. So to this abstract parent class, this will return the type. Okay, so let's see. I want to go now to Atom because I have all this information here, and I don't know why I'm typing it in here because I know what's going to happen. It's going to crash. I should go to Atom. All right, and there's vehicle right there, and it did remember what I typed. Okay, so we know. I'm just going to put a little reference here that we're going to have to do with type, distance, hours, and fuel. I'm doing that because I've been showing you a new way to create two constructors in one, a default constructor and a constructor with parameters. So therefore, when we create a vehicle object, the first one will be a string, which is type. If they don't give us a type, we will say it's an unknown vehicle. A UFO, if you will. Okay, the distance, we know that's going to be of type double. It goes nowhere. Set it equal to 0 if you're a default constructor. The hours, it took no time at all, really. 0.0. How much fuel did it use? Nothing. Very efficient. That's what you get for a default constructor. Okay. Oh, semicolon at the end. And now all the getters. So string, we will get the type. double, get the distance, get the hours, because we're going to need to know that if we want to calculate miles per gallon or miles per hour, so we have to get that from this ancestral class. Get fuel. Okay. Now the other ones we generate because different vehicles travel at different speeds and we're going to handicap the car. What if it's an electric car and it's not getting all the efficiency it can from the battery or from the fuel or from the combination of both? It's supposed to, but let's assume that there's some kind of a scaling factor that all of a sudden now is different. Again, polymorphism. It's different from child to child. So these will be virtual objects. Virtual, double, gets speed, and it returns a void. Virtual, let's, you know what, I keep making mistakes, why don't I just copy this so I can paste it randomly, okay? Double, get fuel, and then that will, well, I have to do something a little tricky there. I'm not going to put a semicolon there just yet. This will be to get the fuel average. This will be a virtual void and print void. And then virtual string for the toString. All right. Now, I don't know whether it's a code blocks thing or not, but I've discovered that in order to make this work so it doesn't blow up in our face, we have to actually declare them here, declare functionality inside this vehicle. Even though they're declared as virtual, we need we need to create them. Okay, so there, get speed, get fuel average. Okay, back to here. Okay, so I've got too many. Fuel I don't need. Sorry. Now, get speed. Because we need to create it, I've always done this. I would say something like return something ridiculous, -8.8. Again, remember, we can go inline and write the function return without having to build a whole new scoped class down later on. So if you get a -8.8, then you know that you did not create this. Okay, something went wrong. Same thing with get fuel average. Let's have that return a -9.9. Okay, void will just return. There's nothing to return. And here in toString, let's let them know that they did something not right. Curly braces there. By saying return hull. All right. So these are the virtuals. We can't create a vehicle object with these. In fact, if I do create a vehicle object in main, you'll see that it's going to blow up on us very quickly and it's going to say you can't do it. Okay, so these, oh, I forgot to declare that these were the publics. Okay, down here now are the privates. And it's the 4 data types. In fact, since I'm going to be lazy, let me copy this, paste it there. I need a string type, double distance, double hours, and double fuel. Okay, good. So that takes care of the definition. Now let's write the methods that go with it. So vehicle, scope, vehicle. All right. So we know it's got 4 parameters, string and 3 double. Okay. I don't know why I put hours there. Those are double. Double's the data type. Okay. Sorry about that. Down here. So string, coming in for the string, we will populate what the type is. Are you a car, boat, bicycle, aeronautic device, etc. Double, I'll say dist because I'm lazy. Double hours, HRS. And double, I'm going to spell out fuel. I'm lazy, but not that lazy. Okay, so now we instantiate them. So type will be assigned type, right? This data type. But it doesn't know we're talking about this type here. So remember we got to do this arrow. Good. So when this type comes in, it will populate up there. Since distance is differently named than distance and hours is differently named than hours, we don't have to do that. So I can say distance will be assigned dist. Hours will be assigned HRS. But since fuel and fuel are spelled the same, I got to use the this operator. This hours. Oh, fuel, excuse me. Fuel is assigned fuel. Okay, great. That's our constructor. Okay, now all of the getters. So string vehicle, and since I spelled vehicle 14 times wrong already, I'm going to copy that. String vehicle, scope, get type. And return what the type is. Okay. What else? Everything else is double. Double vehicle, get distance, return distance. Let's see how much of this I can plagiarize. Copy, paste. Next is we're getting the hours. Return hours. Okay, good. And then finally the get fuel. Get fuel, return fuel. All right, that creates it. Now, let me go now here to main. Here's our welcome code. Now, if I created vehicle, here we go again, VEH1, and call it a skateboard that doesn't have much of anything, maybe for the distance, the hours, and the fuel. All right, if I go back here to code blocks, it'll say, do I want to update everything? Yes, I hit all. And when I run it, okay, I'm getting all sorts of errors. Well, first one, it says that it couldn't get a get hour match, so I must have spelled something wrong in vehicle. Okay, get hours up there. There we go. All right, and so back to here, reload it, run, compile. Okay, and then we run this. Okay, it took care of it. It gave me some 4 blanks. It created this unknown vehicle, but there's nothing really I can do with it. If I go back here to main, if I wanted to know, I don't know, cout VEH1 dot get type. Okay, back here, compile and run it. Okay, it gets a type of a skateboard. But in terms of all the other juicier ones, like the get speed and get fuel, because they're virtual and they haven't been declared, I'm kind of stuck. So I've got this very lame, limping vehicle object that really doesn't serve me well. I don't know anything more about it because I'm more interested in the virtual methods. Right? getting the fuel and the printing it and the toString. Okay, so what I'm going to do is I'm going to comment the skateboard out because it's the car that I'm interested in. So let's go and build the car business. Okay, so the car object, we're going to need some includes up here. Pound include IOStream and pound include string using namespace std. Now all of the vehicle information, which I do need once I import from it, is here in main. So as this thing compiles, it'll compile all of these standard libraries, and then it will bring in vehicle, car, and boat. And since vehicle appears first, it shouldn't have to appear first, but I made it appear first. That way, when it comes time to compile the car will know about it, even though the information isn't included. So I will say class car colon public vehicle. And I'll just put a comment here, inheritance. This is how we designate inheritance in C++. The class car will inherit from vehicle. Okay? And now all the business to write. Don't forget the colon, the semicolon at the end of the delineators. Okay, what's public? Well, a constructor. Okay. The car object, and let's kind of go back here to the Word document. Okay. He has a make and a model, and then all this other business is from the distance, hours, and fuel come from the parent object. And since it's a car, we can actually hard code in that it was a car. We don't need to pass that in from the user. So back to here. So the first parameter is the make. So I'll say, if we don't know what it is as a default, unknown make. Second one is the model, and if you don't put something in, we will say unknown model. Okay. The next is all the distance. That's unknown. Let me break it for the next line. Then the hours is unknown, and the fuel. Again, I'm not using the data type name, I'm just using the alias of what the variable is. Okay? Double distance, double hours, double fuel. Okay. Then a semicolon there. Okay. That will be the constructor. So, let's see. String get make. Nothing goes in it. String get model. Nothing goes in it. All right. Now, we're going to be putting something into the virtuals. Get speed. I've typed double, excuse me. In fact, let's see if I can steal. Okay. I want to get all of these. So I'm going to paste them here and trim off all that business. All right, speed, fuel, print, and toString. Okay. And what are the private methods? String make and string model. Again, looking here, we got it. Make and model. Here's our setters and getters. Here's our virtuals. Now these aren't italicized because when we write them, even though in the constructor we declared them as virtual, when we write them, you got to get rid of the word virtual because then there'll be all sorts of confusion going on as to the fact that we've guaranteed that we've done that. So, okay, so that's it for the attributes. Let's now go to the methods car, scope, car. See how much of this I can steal. Okay, we have string make, string model, again the data type coming in, double dist for distance, double hours, and double fuel. And then what we do is, because we inherited from this, how much of this can we steal and populate the vehicle object? Well, the vehicle object, again, we put a colon there, and we have to say that it's coming from the vehicle, because there are many times in which we have multiple inheritance. Any of my Java programmers know there's no such thing as multiple inheritance. Any biologist knows you can't have more than one mom and one dad. You can't have multiple inheritance, but C++ lets you do that. Okay, so you have to be specific with what you're inheriting from. So the vehicle. The first parameter of the vehicle, if you remember its constructor, was the type, and then all these wonderful things. The distance, the hours, and the fuel. Just making it look nice and pretty, not necessary. Okay, going back here to the car. So the first parameter is the type. It's a car. There we go. We hard code that in. And then what are the other parameters? We're going to get dist from here, hours from here, fuel. This has to be spelled exactly as it is for the input parameters for the car. So it's like saying I'm giving this 5 parameters, but 3 of them are going to be stolen in this exact order with this exact spelling. So, we certainly can't put a semicolon there at the end. That'll doom it. So, the parent call will take care of these 4. Again, one that we don't handle, these other 3. So we have to set make and model. Since they're exactly the same as make and model, here we go. This make is assigned make. This model is assigned model. Okay. All right, that's the constructor. We're still going to need the string get make, and that will be return make. Copy it because it's almost the same as get model. Get model. Return model. Okay, that's looking good. Now we have to handle the virtuals. I'm going to copy all of these to make it easy, and I'm going to paste it right here. Okay. Now, I said you get rid of the word virtual. We still have to give it the car scope, get speed, and then I'll fill that in later. So, being either very lazy or very expeditious, I'm going to get rid of all of that. Again, copy paste is a wonderful thing. Paste that there. And put semicolons at the, or curly braces rather, at the end. And then now we flesh them out. So let's see. Get speed. Well, the speed is miles per hour or distance per hour. So it's return the get distance, because as you know it's private. Even though we inherit from the parent, we can't access it directly. But we can use get distance. Get distance divided by get hours. Okay. Fuel average. That is what? Miles per gallon. So that would be distance per fuel. So that's another get distance over get fuel. Okay. Now the print and the toString. This is kind of like free form. So here's what I have for print. I say cout. This is a, what kind of vehicle is it? Well, call the parent class. Get type. Car, boat, whatever. And I will say of make, and I will output the make, and I have direct access to that. I'll continue this on the next line. Why did you make that capital M on me? And model, return the model. And that's all I'm going to say. I can get all the other parameters, but hey, you're the programmer. If you want to put that in, you can do that, or whatever the boss says. Okay, now what's the toString look like? Remember that we just return a string. Print is different than toString. ToString could be some string that we want to parse. Maybe there's information there. Maybe this toString needs to be dumped to an external file. You very well can't do that with a print. So there's usually a print and a toString in many methods. Okay, so toString. Here's what I'm going to do. I'm going to create a string output variable, and we'll keep appending to it. So I will say that this is, oops, it'll be assigned car, and then we add to that the make. So you can say Dodge Caravan or whatever. And let me put a new line at the end of that. Okay. And then we will append to that using the plus equals operator. It can go. And we want to give it the distance. Now, of course, distance is a double, and we can't append a double to a string. So use the to_string method, and that will turn it into a string, appending string to string. Miles /n I wrote. And the next line is another output equal, so we're building a real big fat output string. It has a speed of, and again another toString, of get speed. Okay. And we know it's going to be based on miles per hour. Other things are at different speeds, but I'm going to append to this mph, and I'm going to give it a /n. Okay, so let's see, the fuel average we had to rate, we got the speed, because that was virtual, we get the fuel average. So let's add to that output. It has a fuel economy of the toString of get fuel average. And since it's a car, it will be plus mpg. We'll do a /n. Okay, and that will build the string, and we can always put more in it, but now return output. Okay, so the reason why I created this all in an output, you can see how long this goes. And by breaking into small pieces like this and appending each new idea, if you will, then we can return the output. Okay. So we built all this stuff, but does it work? Well, who knows? I may have typed something in wrong. You may have seen it, but skipping the skateboard, let's create a car object. I will call it my car, which it is not. I'm going to say it is a Ford Mustang. No, I don't own a Ford Mustang. It can go a distance of 200 miles in 1.8 hours, let's say, with 5.2 gallons of fuel being used. Okay, so let's go see out my car dot toString, and then an end out. Okay. Moment of truth. Save everything. Go back to code blocks. Thank you for not crashing on me, code blocks. There's the main. There we go. Okay. Compile. Oh, how do you like that? Got it all in one shot. Ford Mustang. It can go 200 miles at a speed of 111.1. That's fast. And miles per gallon. Okay, so you can use some formatting tools to strip these down to something more realistic. I forgot to put a space before these. I've got a lot of spaces here. Don't really want that many. So let's go back and do some tidy up. Yeah, that's a lot of new lines. And what was it? It was in the car, right? I didn't put a space between MPH nor miles per gallon. Okay. So that is the car object, and here's again a recap of the usage of the virtual methods. We are guaranteeing that we create them. If we don't create any of these, then there'll be a problem. If I do something like let me do this. Comment out the virtual and just call that double. Okay, yes, refresh, compile. Okay, build. Okay, it took that. Come on, scroll up. I want you to see all the, oh, okay. So in the removal of this, it's thinking that I'm creating my own get fuel average, not the fuel average from the parent. Now, if the parent had a fuel average, now I don't want to start going in and messing up our files, but if I did create a separate fuel average here, or like a separate print method, in fact, well, since I've already done it, let's finish the dirty deed. Okay, gotta hide the body, right? Let me fix this. I can actually, inside vehicle, create a print method. Something like this. What is it? Void. And I do have an example in my notes here. And it's something simple. I will just say cout. This is a type. Okay. Then I go back. Gotta save that. And go back to here. The skateboard. And let's see. Save there. Okay, now we run it, and there's all these errors now because I declared vehicle as, or rather the print method as virtual, and it's telling me that I have a previous definition of it, that I can't do this if, let's see, go back to Adam right now. inside vehicle, I have this definition here, right? So let me just kind of do this. Let me put a semicolon here and a slash there to comment that out. And then here, all compile. All right. And it created that. Now, let's go back to here. And I have to be honest with you, this should not have happened. This should have belched all sorts of vile whatever at me. The fact that I redeclared it here while it was declared as virtual here. So, in fact, in my notes I had this commented out, and that should not be there in the first place. But in the car object here, the inheritance, this is where this forces us, okay? It forces us to create this object with all these properties at the top, and forces us to create these virtual methods. You can't be an ancestor of the vehicle object if you don't make the guarantee to write these 4 methods. Okay? Now, in some cases, and I was testing on another compiler, this did not work at all because I couldn't create it. I couldn't. Oh, wait, not get type, print. No wonder it didn't crash on me. Okay. Now let's try this guy. There we go. Okay. It's crashing on me because I've tried to override it. Okay. So, no, I don't want to exit this just yet. All right. So, sorry about that. So, in my effort to say why didn't this happen, it was because it behaved exactly. It did get the type, but I wasn't allowed to print because print is virtual and wasn't declared, but has to be declared in the others. Okay, so that's the lecture, and you now have a lab that's going to be based on this. I'll put all this code out there on Blackboard for you to make life easy. Okay? Thank you.